In the previous few videos, we've talked about Boyle's law and Charles' law, and in each of those cases, we were discussing just two variables. So in Boyle's law, notice we talked about pressure and volume, and there's that formula we were given. And then in Charles' law, we talked about volume and temperature. I didn't mention it before in a previous video, but you also have this Gay-Lussac's law, which relates pressure and temperature if you ever need that. So P1 over T1 is equal to P2 over T2. So what if we were working with all three, pressure, volume, and temperature? It turns out it's pretty straightforward. We just combine them. So P1 times V1 is equal to P2 times V2. V1 over T1 is equal to V2 over T2. Our combined gas law just sort of literally combines those two. So P1 times V1 over T2 is equal to P2 times V2 over T2. You may also see some problems in chemistry that mention standard temperature and pressure, which they call STP. If you're ever given conditions that says you start out with something at STP, all that means is our standard temperature, which is 0 degrees Celsius, and standard pressure, 1 atm. Notice that that's 0 degrees Celsius. You will have to convert that to Kelvin. So keep that in mind when you're working with STP, or standard temperature and pressure. So let's go ahead and look at a problem using our combined gas law. We said that a 40-liter balloon was filled with air at sea level, and it even gave us that sea level was 1 atmosphere and 25 degrees Celsius. And it's then tied to a rock, and we throw that balloon into a cold body of water so that it begins to sink. And then it sinks to a point where the temperature is now 4 degrees Celsius. Notice we've gone down from 25 degrees Celsius. And the pressure has now increased to 11 atmospheres. So we want to know, what is that new volume of the balloon? How will it change if we change that temperature and that pressure? So just like before, I went ahead and pulled out our variables. So P1, V1, and T1 were all given from that statement. Notice I had to convert T1 into Kelvin. So I took that 25 degrees Celsius plus 273 to get 298 Kelvin. And then I wanted to know P2, V2, and T2. Notice that the pressure and the temperature were both given in the equation. Again, convert that temperature to Kelvin. And we're solving for V2. So here's our combined gas law. That's what we already know, that the equation that works. And I'm going to go ahead and make sure that V2 is on its own. So you'll have to multiply both sides by that T2 and then divide both sides by P2. And you're left with this. So V2 is equal to P1 times V1 times T2 over T1 times P2. So it looks pretty complicated, but you already have all of those values on the right-hand side. So we can just plug those in. Again, always make sure pressure is in atmospheres, volume is in liters, and temperature is in Kelvin, which we double-checked, and that all checks out for us. You can cancel those atmospheres since they're on the top and bottom, and you can cancel Kelvin since they're again on the top and the bottom, and you will be left with a volume of 3.38 liters. That's rounded to those 3 decimal points, or those 3 significant figures, since that's what we had in the question. And that is our final answer using our combined gas law.